about working with remotes. And here is the concept of the remote repository, yes, in Git. It is basically a reference to another project, yes, which can be hosted in several places, including your local machine, yes, or over the network. We have seen that the process of cloning, right, it involves a remote repository already. And in this remote project, you and your collaborators can push or pull a code, right? Modifications. So a remote is a way to back up your repository in a very concise manner. So here I show you the workflow with two persons, right? Three persons in this case. So where we are sharing the same project, yes, we are working on the same project, and then we put changes, yes, and we keep all these changes consistent over the time. So here we have a common repository, which in our cases is a remote, right? And we can get this remote and have a complete repository with all the history of the commits and the files, right? So all of us can keep this very same information. And then when we update our own repository, we can also put the changes into the remote so that all the collaborators can also get the same changes and keep synchronized over the time. So there are several platforms where you can put the remotes. And in the present course, we have seen several times how to use GitHub, how to clone a remote from GitHub. But there are also other services like GitLab, Bitbucket, or even, as I mentioned in my first lecture, so maybe is one of your collaborators, yes, set already a repository in one computer at your department, yes, and then you can also get this repository, yes, if you have permissions to do that, and then you can start working as a collaborator to that project. So this is why it is useful, right? So you will get the entire history, and then you can also put your own changes to that repository. So I come back to the initial picture that I mentioned in my first lecture for the stages of the files in Git. And there I mentioned that in the first lecture, yes, we would be working on the local repository, which is this big folder, right? And we will touch now the remote repository, yes, which is a copy of the project, yes, that we want to get. So here are the initial concepts. Yes. How do we know what remotes are available in our current project? So we can type, for instance, a git remote -v, And this will display the remotes that are already set up, where you can get the changes, yes, which means you can fetch or pull the changes, or you can even push the changes. So you will put the changes on the remote repository. So this command gives you the name of the remotes, and in this case, we have only one repository remote that is called the origin, and this is the default one when you clone a repository from GitHub, right? So if you clone the repository, then you will see this origin already present. But if you created your own repository from scratch, so imagine that you have several source files, you're developing some code, or you're writing your scripts, and then you started or you initialize the Git repository with Git init, then in that case, you won't see any output from Git remote, right? It will be empty until you set some remote. So in the repository containing the origin remote, if you clone the repository, for instance, so you can see the output, right, or the information about this origin when you type the git graph command. So this is the alias that we created in the basic command sessions, and this is an alias of the longer command for git one line graph and decorate. So if you type this command git graph, then you will see the information of the main branch and the origin, which is the remote. So as you can see here, in this case, everything is synchronized. The main branch in the local repository is synchronized with the origin main branch, right? And head. But once you start working and committing on your own branch, then uh, uh, you will see that the the three the three branches are not synchronized, and then you will see the situations as previously with the Birgitte and Diana. But at this point, you see that you see that they are all synchronized. I haven't done any changes to the local repository. So one can add the repositories manually, yes, besides the one that is obtained from GitHub. I mentioned that the origin, yes, one can add other remotes manually with the git remote add command. And here you put the remote name and the location, so where you will want it to be. So this is an example, right? Let me see here. So first I can create a directory. Here there is a mistake. Yes, you notice that most likely this is an I, yes, not a Y, mkdir repo, and then cd my repo. And this is an empty folder, right? So then I can initialize it. as we have done it in previously. And we can check the status. And you see that here we have a master branch and the node commits have been done yet. Yeah. So if we check the remotes, you see that it's empty because it's a repository created from scratch. Yes, that's why we don't have the default origin from GitHub. But we can also add uh, our origin, yes, with the git remote add command. Let me see this one. So this is a repository that is present in my GitHub account, and you can use another one on GitHub if you wish, which is public. And then I can check the remotes, and you see that the origin is now present. I call it origin, yes, but you can name it as you wish. So yes, in this case, I use a URL because this is a repository that is present on GitHub. But if you have a path for a local repository in your machine, then it can also be used as a remote. Yes, and add it with a path to that repository. So there are several protocols that are used in GitHub, yes, to get the remotes. One of them is the local. We saw that if you have a local repository on a local computer, right? Then you just write the path. Yes, in this case, the path is the opt git project.gat. One can also use the SSH protocol. Yes, and this is the one that can be used with GitHub, especially if you have the recommended SSH keys, right, as Birgitte mentioned previously. Or there is also the option of HTTP. This is also available on GitHub. And the less common is the Git protocol, which is not secure for transferring, but it's also could be also fast. So how do you work with the remotes? So once you have your remote added, yes, you can put changes to the remote with the command git push, yes, and the remote name, and then the branch name that you want to where you want to push the changes. Yes, you can also fetch the changes from the origin and the branch name into the current branch name or the branch name that matches the name. And also you can pull the changes, yes, from the remote to the to the branch name in the remote, right? So we saw this before. So if you obtain the repository by cloning an existing one, then you will have the origin remote. In this case, you can put your changes in the origin master branch by using this command. Yeah. You can also fetch the changes from the origin master and also pull the changes from the origin master. So we'll see the difference between these two commands, which sounds similar, but they are not the same. So, or by default, yes, because origin is a default name. So instead of writing these long commands, you can simply do a git push, a git fetch, or git pull without origin master. So the git pull command brings all the changes in the branches that are in the remote, and then it tries to merge the changes in the current branch of the local repository. Yes. So it does two things. It brings the changes, right? And also it merges the changes with the current branch in the local repository. So this is a detail, and this is just for your knowledge. So you don't need to modify the defaults behavior of git pull, but they can be found here. Yes, where you can see how the remote branches are merged into the current ones. So the git pull is a combination of two commands. First, it can be split into two parts. The first one is git fetch, the remote name and the branch name, and then a git merge is applied with the git remote name and the branch name. Or we saw that for the origin remote, we can write just git fetch and then git merge. This is the effect is the same. So how does it work? So here you notice that I added a remote, yes, from GitHub, and this was an empty project. So if I type git status, it still says that the not commit has have been done yet, right? So there are not commit present in this repository. And then let me do a git graph, where the git graph is the alias that I showed you previously. And this is empty, yes, because I just added the remote at this point, right? So, but then I can start working with the remote. And the first thing that I can do in this case is to get the history or get the history and the Git files in my current local repository. So how can I do this? I can do a Git fetch origin master, yeah, and then it fetches the changes, right? So now I can, well, let me see the content of the directory, and it is still empty, right? Because I just fetch the changes as the name suggests, yeah. But these changes are not uh, merged into my current repository. So I can see the effect of fetch if I type again a git graph, and you can see here that the remote master called origin is already here. Yes, the changes are present in my local repository, but uh, they are not a merge. So, so at this point we are here. Let me move a bit up. So what I did in this case, right, was to get or to fetch the remote repository, and then I copy the remote branch, yes, in my local repository. But these files here are not present, yes, in my working directory, in this staging, and my local branches, right? So I just fetch this folder here. So this was the effect of fetch, right? And what can I do now? I can then merge the changes, right? Git merge origin, master, yeah. And now that I merge the changes, I can see the following. The master branch, yes, is synchronized with the origin master, and the files in the remote, which is just one, is now present here in my local repository. So I did these two commands. I executed these two commands, right? But I can execute a single one that I mentioned previously, git pull origin master, right? And this will be this will do the two commands that I mentioned, git fetch and git merge. It's convenient to first fetch the changes, then see if the modifications agree with what you want to do, and then merge the changes. This is useful if you are developing code, for instance, and you don't want to include features that can break your current development. But otherwise, you can summarize the two commands. So the command git push will send the changes in the current branch to the remote by default, right? So if you type here git push origin master after doing some changes, then it will send the changes to the GitHub origin remote, right? And this will be doable if you set the SSH keys that Birgitte mentioned previously. So otherwise, you won't be able to put your changes in the GitHub platform. So one can also alter the behavior of a git push, but this is also advanced, right? So sometimes you want some specific behavior of git push, right? So then you can alter the behavior, yes, by choosing the way in which the remote branches are pushed, right? So for instance, the default here, when I type this command in my repository, it was matching, right? So which means that GitHub or Git will try to match the remote branches, right, to my current branches, and then it will try to push the changes accordingly. But also one can use other options, right? And then you could see a different behavior. So imagine that you have a brand new branch. You create a branch that was mentioned previously by Birgitte. And in this case, my branch is called new, right? And it's not present in the remote, right? So the first time that I want to push this branch to the remote, I need to use an option here, which is called U, right? And then this will make a Git start tracking the remote branch as well. So this is equivalent to two commands. First, git push origin new, and then you set the upstream branch new to the origin new. Then you will be able to push and pull the changes in that branch by simply typing git push or git pull as we did now. So how to show the remote information? So here you can see the output for a test case that I had, right? That is more elaborated than the one that I cloned here, right? And here you can see the remotes, right? The remotes and also the remote branches, the local branches, yes, and where I am fetching and also where I am pushing. Yes. So this can be useful, especially if you have several remotes, as I will show you later on. So one can also rename the remotes with the git remote rename command. And here you give an initial name and then a new name. For instance, imagine that I want to rename my origin. You remember, I can list the remotes with git remote -b. Then I can rename it git remote rename origin to, I will call it default. Okay? So then if I type again git remote -v, it will be called now a default. I will reverse this change here, default to origin. But the changes need to be accordingly, right, to the local repository and also the remote repository. So one can also delete remote if you don't want to track a certain remote anymore. Then you can remove it from your list with the remote command. Bare repositories. This is a more specific topic, yes. And this can be helpful, yes, in some cases, and I will mention it just briefly, but this is not that common, right? So we have seen this picture previously, where we had a local repository, a working directory, index staging, local branches, and some remote, yes, where we were from where we got the initial repository. So basically a bare repository is a repository where you don't have a working directory. So sometimes this is convenient, especially if you have several source files or several files as when you are developing your code, right? And you only need to have the staging area, local branches, right? So no one is working in that particular repository, but the people or your collaborators are only sending the changes to this repository. In that case, if no one is working in that directory, then the working directory is not needed, which could reduce the size of the whole folder. So how can you create a bare repository? So you start, or you make or create a folder, in this case called bare.git, then move to that directory, and then you initialize the directory, but with the dash dash bare option. Yes. So this is more specific, and if you need it, you can try that. Then if you want to clone the bare repository, then you can use the dash dash bare and the path to that folder, right? And in this case, it's a location the in a local machine, yes, that is available to you. So we have seen with Birgitte how to start with GitHub, and then here we can create an account. Yes, you follow, I hope, these steps to get an account of GitHub, and also you set the SH keys, right? And then once we have an account on GitHub, we can see this interface, right? And we can start the process of creating a repository, which can be our remote in this context. So here in my case, I can see my username, and in this button here, I can start creating a new repository. Yes. We can choose the options, public or private. And if we want to add some README or git ignore files, so then we can choose a suitable name for the repository and click the options to create the repository. So then Git suggests some steps after you create your repository, which will be your remote, yes, in this case. So here you will see some options, and currently these options changed a little bit, yes, because now in GitHub the previously called master branch is now called main, right? So then you will need to set the name or change the name from master to main and follow the instructions that the GitHub gives you here. But because I am working on Kebnekaise, you can see that Kebnekaise, the version of Git on Kebnekaise still accepts the master branch, and I created my repository at the time when master was common, right? That's why I didn't have this situation. So here Git suggests to create a new repository on the command line, and this is the step that I follow. As you remember, I created a folder. Then in this folder, I did an initialization. Then one can add some file, And then one can name the master. And here I added the origin, yes, the remote origin. And then I push the origin master. So this is when you start from scratch, yes. And here is how to push an existing repository from the command line, or if you want to import the code from another repository, for instance, Mercurial or another type of public repository. One can also import this in GitHub. Notice here that I started from this part and I choose an empty repository, yes, without the README file, right? Because this README file was present already in my repository, right? So if you have already a README file, you create a folder, then you add the README file, and this file has a different content than in the initial README file from GitHub. Then you will see conflicts, right? That's why I prefer to start from an empty folder, right? Then add the remote and then start working. So in GitHub, you can find different features, and I will mention just a couple of them. So in this case, it's network visualization. So you go to Insight and then go to network. And here you will see how your collaborators are committing, right? And the history of the commits in a graphical manner. And this is very useful if you are working with several collaborators and also if there are several branches. So in this case, you can see that I have only one branch and this user has been committing several times. At some point, there have been some merge processes, yeah, and this can be explored with the network graph option. So at this point, we have just added a single remote, yes, but we can work with several remotes at the time. So I will describe the following scenario where several remotes uh, can be needed. So imagine that, so Alice, yes, uh, search on the internet and found that Bob had already a repository with some interesting code, right, that she wants to get. So one way to work for this scenario is what we just did. Yes, we can clone the repository from Bob, and then Alice can start working with the clone repository. Yes, but then if Alice wants to make Bob aware of some new features that she added to the code, she won't be able to push the changes on the Bob's repository because most likely she doesn't have permissions to do that, right? So we have seen that we need to get the permissions from the owner of the repository. So, but locally, Alice can work on this clone repository, and if no changes need to be committed on the Bob repository, then it's fine. So, a better approach to work in this case is as follows. So we can take the Bob's repository, yeah, and then Alice can do the so-called fork. Yeah. So she can fork the Bob's repository, and then based on this fork repository, Alice can start working, and because she has access, if she set already the SSH keys that Birgit mentioned, yeah. So then she can get or clone their fork repository, yes, into her local PC, and then here she can push or pull changes, right? Because she has permissions to write on the remote. What she cannot do is to push changes to the Bob repository. So how can we solve this? So we can create the so-called pull request, yeah, where Alice requests a pull from Bob, and then Bob can analyze the content of the new code, the new features, and evaluate if he wants to get these modifications into his repository. So how does it work? So we have in this case two users, right? And I think we can have a pause here, a break for let me see, with this lecture. So we saw before, yes, that a better approach to work with another repository is by using the forking option. And I will describe how this process is done. Yeah? So imagine that we have two uh, persons, Bob and Alice, as I mentioned before. So then Bob has some existing repository with a code that Alice considers useful, right? Yes, this is the Bob account, the Bob repository. Yeah. And then uh, Alice also has an account, yes. And what she can do is she can go to the Bob repository here while being in her account. Yeah? So then she can click on the option for forking, yes, and then the forking will start, yes. And once the forking process finishes, then she will see on her GitHub account that the project was forked, and also she will see the origin of or the remote where this project was forked, right? So then when she does some modifications to the project, so there will be an option in GitHub which will tell her if the repository or her repository is synchronized with the Bob's repository. For instance, in this case, I already fork, yes, and here you can see an option which tells her that the repository is synchronized with the Bob's repository. Yeah. So what is the main thing here? Here is that Alice can work on her fork repository, yes, by cloning it, and she can do simply with the cloning option. Oops, where's it? Cloning option here. And for the SSH feature that was mentioned, yes. So she can get she can clone the code in this part, yeah. And as you can see here, in the case of this user, yes, the SSH keys haven't been set, and they need to be set, as Birgitte mentioned, to be able to clone from the SSH option. And once this step is performed, yes, then one can clone from this repository, and one can fetch and push changes to this local repository. Yeah. And also, Alice will be aware of the changes that Bob does, because here in this case, in this GitHub platform, so we will see the option, yes, for synchronizing with the Bob's repository. So manually, what can we do? So here, Alice can add the origin. So in case this is an empty folder and she didn't copy, or she didn't clone the remote, yes. So one can add the origin, and then one can see the origin. And then one can also track the remote, yes, from Bob, which was the user who owned the initial repository. Yes. And we can call it upstream remote. You can call it as you wish. So here you add the upstream, which was the Bob's repository, and also here you can see the information was once this remote is added. So then you can fetch the master branch from the Bob's repository, which is called upstream in this case. And then once you fetch the master branch, you will see this with the git graph command. So here you see that this can be more elaborated than what we have seen up to now, because here we have the main branch, right? We have also the origin, main, and head. And in addition to this, we have the upstream, which is the one from the original repository from Bob. And here we cannot push changes because we don't have access. Yeah. Unless Bob gives you access to do that. So at this point, these remotes and the main branches are synchronized, but once you start committing, yes, they will be out of sync. Yeah? And the way to keep updated with the origin will be through pushing and pulling, where you have access to push and pull. And in the case of Bob, it will be through a pull request that I will mention right now. So synchronizing the remotes. So imagine that now Alice makes some changes to her fork repository, and then she wants Bob to be aware of them. And in this case, it's just one commit, right? So she pushed one commit, yes, to her fork repository, and then on the GitHub account of Alice, she sees this option. The branch is one commit ahead of Bob user. Yes. So then she can click on this commit. Yes. On this link, and then here a pull request is suggested. So which means that she will request Bob to inspect the changes and eventually merge the changes into his own repository. So because this was a very small change and there is no conflict, yes, between the changes, yes. So Bob hasn't changed anything in the same file, for instance, then it tells you that the two branches are able to merge. Yeah. Otherwise, if both users made modifications to the same file, then there will be conflicts that you will need to merge manually, as Diana mentioned in the previous lecture. So these are able to emerge. So then you can create a pull request. Yeah. Then here the pull request is created with this button. And also there is another way to create a pull request in a pull request option. Yes, on GitHub, this one. And once the pull request is created, then Bob receives an email and he will be aware of the change, of the modification of Alice, and then he can inspect the new code or the new changes that she proposes, and eventually he can take the changes or don't accept the changes. So then this is the Bob account, and he will see that there is a new pull request. He can click on this button here, pull request, and then he will see that there is a change proposed by Alice. Yeah. And here you see that there is no conflict with the base branch, and then he can merge the pull request if he wants. Yeah. And then, so this can be merged. And here you see that everything was merged without any further issues. And then now Bob has the changes proposed by Alice. Yeah. So here I mention another feature in GitHub, which is the issues. So here we are in the Bob user, yes, account, and we can see an option for issues where you can write about different problems or different situations that could be improved in your current repository. Yes. And then here you will get a number for the issue. So you can track that number in your commit messages, right? As it is here. So there is a number for each issue. And then when you write your commits, you can refer to these numbers, yes, and then track the issues in the commits that you make in this repository. So then when you click on the number in the commit, then GitHub will send you to, to the corresponding issue number. So this is something extra about the practices that you could have in your in your workflow. So communication with the colleagues is crucial, especially if there are several colleagues. Yep. Notice that some commands as Git rebased, that was mentioned during this course, can change the history, and there are also other commands. So if you're working locally in your local repository or your local branch, for instance, and this is not public, then it's a good idea to use them. But otherwise, if you're working with public branches, then this will modify the history and will create conflicts with the others repository. So don't accept pull requests immediately. One needs to inspect them, yes, carefully to avoid problems with the code, right? Especially if the changes could introduce a bug in the code or some conflict with other files. So that's it from my side for this part. So we have two exercises in the folder. So if you go to the exercises, so you will see the corresponding exercises here in working with remotes. And there are two exercises for this part. So I can do something similar to what Diana and Birgitte did previously, and we can go to a breakout room and explain the exercises if you wish, or you can stay in the main room, yes, if you are comfortable with working by yourself on the exercises. So the exercises can be found in the Git materials 6 remotes, and then I will start with the first one. Yep. Adding remotes. Let me see where is my terminal. So here it says forking the remote repository. So here you need to go to this page in your own account. Yeah. And then you will see this repository, and then you can fork it in this with this option, right? So it will tell you if you want to create a fork, then you can create a fork. Yes, in this case, I cannot uh, do this because this is my own yes, account. Yes, but otherwise you can create a fork. Then in the fork repository can be used, right, as the origin, and you can use the upstream repository with the name upstream. So this is what I mentioned previously. So maybe I can do this with a different repository. So here, for instance, we have this repository. So we can fork it. And here you can see that the repository was forked. Yes. And we can use this as the origin if we clone this, right? And the initial one will be the upstream, which is this initial repository. Then here you can do some modification to the file, in this case the README file, and commit them locally, and then push the changes to the remote. So here I will need to make changes to the file. So in this case, right, this is my fork repository, yeah, and I can do some modifications to it. So there are several ways to do the modifications. One is when you clone the repository and set the origin, as I mentioned. Yes, you clone the repository, you will have already the origin, sorry. And then you can set the upstream, right? A very fast way to do the modifications to my fork repository is if I go to the edit mode, yeah? And then here I can do some modification. Yeah? I will delete some lines here. Then I can commit the changes. We'll write November 6th. So if I go to the repository page, I see that there is a commit ahead. Yes, then uh, I can click on the commit message and it says that it is able to merge. And here I can create a pull request, right? So in the pull request, I create a pull request. And then in this case, the owner of the repository will receive a message and we will be able to merge the request. So this involves the usage of your account, as you can see here. And then in my case, I will receive a message from you, and then I will accept the pull request. Well, inspect the pull request and see if we can merge it. So in the second exercise, we need to merge conflict and rebase. So I will go to the second exercise. And here there are the instructions. Let me reduce it. So here we should enter to the repository folder, yeah, and check the file, yes, file.txt, and see if it has been modified. So we can check the status of the repository, and you see that the file was modified. Yeah, so it needs to be added and committed. So we can check the difference in this file. You see that now we have this line, and previously we have a different line, right? So this is the modification that we need to commit. So we can commit the changes and push them to the remote. So we first add the file .txt, git commit -m, and we can say first line changed. Then here we can use the git graph command. Is the alias that we created previously. And we see here how is the commit tree. So we have here the origin master that is behind, yes, the master branch now, yeah, because we added a different line here. Yeah. So we check the status, and it tells us that the branch is ahead by one commit. So we can try to push, and it tells us that we cannot push, yes, because there are some changes in the remote, yeah, that are not compatible with the local changes. So this suggests something here, git pull, right, before pushing. So we need to pull the changes from the remote, and this lead us to a merging commit. Then we create a merge, check the status, and now we can push. Let me see. Let's check the Git graph. Yeah. And you see that now the origin has been merged with, with the master branch. We are here. And we need to synchronize the changes. We can do some git push. Yeah. Analyze again the graph, and they are now synchronized. But you see here that we have created a new commit. Yes. And maybe in this case, it's not necessary because uh, we could simply rebase the branch, right? Because there was only a single a line that was modified. So let's reverse the status, yes, and reverse that to the previous commit. Yeah. So we see the graph now. So we reversed the status up to this point. And then instead of trying to pull, we will do a pull rebase, yeah, which will just rebase the master branch. Yeah, so, or in this case, yes, because this was a very short change, short modification, Git is able to figure it out, and yes, and we can avoid the commit message for this case only. Yeah. But for more difficult situations, conflicts can arise, yeah, and then we will need to manually fix the conflicts. So is there any questions about this?